Drew's going to show the peepcode app, so I'm going to move that we nominate the peepcode app as the official mascot of Orange County EmberJs. And so, without further ado, he's going to explain to me, anyways, what a HAL API is.
Yeah. All right. I'm Ken. I recall that last month we were talking a little bit about alternatives to Ember Data, and people were interested in, well, okay, if you're not using Ember Data for your models, how do your models work? And so today I'm going to show you a little bit of what we use at hotlook.com, which is a bunch of us are from there, in order to consume our API, present models in Ember applications, and have everything, all this fancy magic, right? First question you might be asking yourself is, what the hell is HAL, right? So HAL is Hypertext Application Language. We can click into this URL in a second, but it's essentially, so people who are super into HAL APIs will give you like academic explanations of what it is. Like, I'm a front-end developer. I think of things in terms of JavaScript objects and stuff, so that's how I'm going to present it to you. I think of HAL API as an API where the response I get back is a HAL resource. And what is a HAL resource? Well, a HAL resource is just the same thing as a JSON object, except it has two special properties, links and embedded resources. So if we think of a resource in HAL, this diagram is showing us the three parts of a HAL resource. So the first part is just that, the resource's state. So if we're talking about food, for example, in part of the peepcode application, food is a resource that has, I think, like a name and a price, which is in cents, right? Mm-hmm. Those would be its plain old JSON properties. A resource also has links, which is a hash. So it's a collection, but it's actually it's a hash. The key part of the hash is a string called the relation, and the value part of the hash is something that it turns into an href. Basically, it's a pointer to some URL. And then a resource can have embedded resources, and so it's kind of like the nesting of those Russian nesting dolls. Mm-hmm. Yet embedded resources can be embedded resources, can have embedded resources. Okay, well, that's a lot of words. Here's an example of a resource, right? So this is a food resource from the peepcode application. We see the special property here called links. It's got one link named self, and self has an href to some URL. So let's look at some other examples. That HAL page that I linked to before, this is basically the RFC for HAL. It's a pretty small document as far as RFCs go, and it's got some really good information at a high level here. I particularly like this section. So this paragraph here is pointing out that HAL is intended to be a lot like web pages, right? So we're humans and we consume web pages, and generally we don't necessarily know the exact URL that we want to go to, but we start somewhere, right? We usually start maybe at google.com. And we start there and we enter in a query, and we get back a set of results, and those results contain links. And we as humans click a link and we go to a page, and maybe we click a couple more links until we get to what we want. Well, HAL is really doing the same thing with machine actors instead of human actors. But resources point to other resources, and you might start at a top-level resource, and you follow links between resources until you get what you want.
Is this a specific implementation of hypermedia?
It is a specific. I think the answer to that is yes.
Yes.
Yeah. So hypermedia. I think hypermedia is a term that's come about because the community in general has sort of bastardized the REST term, and so people who are sort of purists brought back a new term to mean like pure REST, right? And that's
REST is over.
Rest, yeah. Rest is ruined. Rest is over. Yeah.
So over.
So over. So now it's all about hypermedia, and HAL is an implemented, like something you can use to implement a hypermedia API. So you know that image looks familiar, and then it has some examples here. So we saw a food example, which was pretty simplistic. Here's an example. That's probably pretty hard to read, right? Here's another example of something, of a little bit more complex resource. So we see the two special properties, right? Links and embedded. And it's got its own sort of object state. This is a collection of orders, right? So currently processing 14, shipped today 20. We have links to go to next, to find. This link is templated. So if we wanted to know, hey, I want my API to tell me how to access order number 32, do I really need to have a link for every one of my orders? No, you can have a templated URL. The application knows how to, so that template is in a RFC as well. There's libraries around there, so you just point this template at a JSON object, it expands everything, you get a nice URL. Embeddeds. So this resource has embedded resources. In fact, it has embedded orders, and it's got two orders that are embedded. So, and each one of these resources also has a link section. They could have embedded resources, these ones don't. But that's sort of what a HAL resource looks like. Okay, so the first thing I...
Quick question. What's the difference between the attributes that were at the top level of each object and then what is called embedded?
So the embeddeds are actually completely different objects, right? So in this example, there's sort of like a top level... This API is returning sort of a top level object saying, you asked me about orders, I'll tell you there are 14 currently processing orders, and there have been 20 orders shipped today. And I'll tell you I'll give you all the orders as well. And these orders are actually like actual resources themselves. So I could come to this URL and get just this one object, right? Mm-hmm. But it's being, I think in Ember Data they call it side loading. Is that like where they get all the extra, all your sort of dependencies, your children references and stuff. That's what's going on here. These are basically this is a master-parent or a parent-child relationship, and these are the children that are going along with it.
Thank you.
Yeah. Oops. Okay. So let's look at the commit. So the first thing I did when I was converting the peepcode application to HAL was I had to replace the models, right, or the fixtures. So inside the peepcode application, at the bottom of the app.js, is a hard-coded representation of the data that we're going to be using, right? So there's tables, there's tabs, there's tab items, and there's food. And generally, in a real application, we'd be pulling that stuff down from an API server. But this peepcode application, to keep it real simplistic, they just hard code that data right into the application. So I'm going to follow along with what they did and just hard code our HAL stuff into the application as well. So here we have this is what was removed. We have a collection food. We've got 5 different food records, pizza, pancakes, fries, hot dog, birthday cake. Here's a replacement of all that same hard-coded stuff as HAL resources. So I'm going to scroll all the way down to the bottom real quick and show you the food one, right? So the food resource, all it has is a collection, right? So a collection is represented by embedding other resources. Mm-hmm. So it's got embedded resources, and we've named these example.com/rel/food. Now this string is a little bit misleading because it really looks like a URL, right? But really this is just it could be anything. I could have called it pretty much anything. Now, HAL has some restrictions on what valid values can be in here. So I think it's got like, it supports orders and sort of like really common things. If you're not doing anything super common and you want to be like really purist and HAL compliant, then you gotta switch it to something that looks like a URL. So that's what's going on here. A real good indication that something isn't a real URL, but actually just something we're using as a string key is this inclusion of the rel keyword here. If you see a URL and it says rel, that's just it's just a string. It could be any string. It's not a real URL. I'll contrast that to the URL here. This is a real URL. It doesn't have rel. So, you know, we have our food fixture. We've got 5 foods here. So same properties: name, image, URL, sense, and we've got our bigger response up here, the tables. So that's got a collection of tables. There's 1, 2, 3, 4. There's 6 tables. And for the fourth one, so 5, 6, for the fourth one, we preloaded it with some data, right? So table has an ID, it's got a set of tab items. Each tab item is a resource, it's got its links, or it's got its sense, and then it's got the embedded food object that was there. So this is real comparable to this block of code up here, right? So it's got 6 tables, each, oh dear. So 6 tables, each table has a tab. Table 4 has a preloaded check with 5 items on the check. Okay. So as we look at HAL objects, how we work with them, we actually only need 2 things to work with the HAL objects. We need a way of saying, hey, resource, I know you know about links. I really need to know the href of some link. I'm going to give you the resource, I'm going to tell you the relation, and if it's a templated URL, I'll give you the information you need to expand that. And you just give me the string back. And I'm going to use that to go and make an AJAX request for some subsequent resource, right? And then the other thing we need is, hey, resource, you have embedded resources. I'd like you to give me those embedded resources. So if we were to come up with an API for working with HAL objects, we would only need these 2 functions. They'd be really easy to implement. This templating stuff might be a little bit trickier, but there's libraries out there that do it for you on GitHub. So you just add in that library as a dependency. You're good to go. Very little code. Okay, so we talked about HAL objects and HAL resources and how they're really similar to just plain old JSON objects with some special characteristics. What about models? What does it mean for a class or an object to be a model in Ember? And how do models work in Ember, right? So Ember has some entry points into your single page application, and those are always handled by routes, right? So a route wakes up because you've entered the application, and one of the things that a route does is it instantiates your model and passes it on to a controller, and it also does views and puts them in DOMs and stuff. But that action of instantiating the model and passing it to the controller is sort of a convention in Ember that Ember Data makes use of, and that if we're going to come up with our own models, we would probably want to follow along with that convention too. So if we look at the source code for Ember, we can see that Ember does some special, I forgot to preload that, some special stuff in the model method of a route. So for those of you who aren't that familiar, a page in an Ember application starts out by a route. A route fires up, and it does a couple things. One of the things that it does is say, what is the model for this route? So imagine you have a route that is /posts /13, right? So 13 is your ID for your blog. Your model method for that route is responsible for taking the value 13, going to the database or your API, getting the value back, and passing it to your controller. Well, the default implementation of the model makes some assumptions. It says, so you've got a route that has a, let's say you've got a route that has a URL that looks like, you know, post ID. Ember, by convention, and unless you override the model method to do something differently, is going to look at this part. Oh, so this would match an example URL. And this is the definition. So Ember's going to say, it's going to look at this dynamic segment, and it's going to say, oh, it looks like you're trying to load something that has an ID. And I see that the first part of the ID is post. So I'm going to look for a model called app.post. And on that model, I'm going to call the find method, and I'm going to pass in whatever this value is. So in this case, it would pass in 13. So this is a convention that Ember set up and that Ember Data supports, and hey, maybe we should support it too, right? This is informing our construction of our models, right? Sure, nothing would break if we didn't do the same thing, but if Ember tells us, like, if Ember makes some expectations, let's try and meet those expectations. So we know that our models need this find method, and what are some the characteristics of this find method? So a find method can return either a single object or a collection of objects. In the example of, hey, we're loading post number 13. Our find object would return exactly one post model, right? But what if we were loading, you know, sort of the index page where we're listing all of the posts on a website? We would call find with no parameters, and we'd get back a list of all of the posts. So, you know, the first thing to note is that it can return a single or a collection. Another really important characteristic of the find method is that it always returns something immediately. Okay, so Ember allows us to say, here's the instance of the model. I haven't loaded the data yet. Eventually, my data will be loaded, and I'll populate this instance of the model. But right now, you can go ahead and data bind to this model. When I know the name, or a first name, or the last name, my object will be updated. And since Ember works by, you know, data binding everything, my DOM will be updated. So our find method needs to behave the same way. So, you know, the first thing I did was convert our fixtures. The next thing I did was convert the models. So I ripped out the app.store equals ds.storeExtend. This is purely an Ember Data thing. And Ember had, or peepcode had already defined a model, right? App.table is a model. It's ds model, it's extending ds.model. Okay, so for our model, I've chosen to extend object proxy. There really aren't any rules about what this object has to do except have a find method. And other than that, we can implement it any way we want. So this could be an Ember object, but in this case, the Ember object proxy has some special characteristics that give us a lot of really nice stuff, and so I've chosen to use that. Okay, so I've created my model, and now I'm reopening the class to define a class level / static function called find. And here we see we're creating an array immediately, and we're returning that array immediately. And here we've got a little note that we need to populate the results with instances of our model, right? So do the same thing for the food one here. So now we need to sort of marry the concepts of, so we know what HAL objects are and HAL resources. They're pretty simple to work with. We know what Ember models are. How do we sort of marry those two concepts together? So we iterated on this a couple times, and we came up with an API that we feel works really well for the majority of our use cases. So our API is totally promise-centric, okay? Maybe I'll skip ahead to do that first. Is anybody not totally clear about what promises are? Should I cover that? Doesn't look like everyone want that. Okay, so it's totally promise-centric. So essentially what we do is we have two methods for getting a promise, right? We're all familiar with a really common one, which is the jQuery AJAX function. We call jQuery AJAX, we get an instance of a promise. Well, that's really cool when what we want to work with is something on some server, right? But what if we already have it in memory? And so we created a function called startWith, and this returns a promise, but the promise is immediately resolved with whatever I've passed in. So that allows me to get access to a promise that has these extension methods on it, without forcing me to do an AJAX request first. You know, maybe I already have the resource in memory, and I can work with it like that. And then we've got a couple functions here for navigating resources. So we've got the ability to follow links and get embedded resources. And then once we have these resources, we have the ability of creating models, setting properties on models, and adding objects to arrays. So there's not a lot there, but it allows us to do pretty much everything that we've needed to do so far. So let me show you an example. What does that code look like? So I've added in this commit. I added some of the libraries that we use on our website. I'd like to open source those, but I think I'm showing here that what they're doing is pretty simplistic, and if somebody were wanting access to this stuff right away, they could probably develop it without too much time investment. Okay, so remember when we introduced the models in our last commit, I had a couple like horrible to-do comments, right? So we got rid of the to-dos, and we have some code here of what we're doing. So I'll walk through these line by line. So this first line, line 64, that's saying we've already got a HAL resource, right? Our app.table response, that's hard-coded to fixture, and we already have it. We don't need to download it from a server. But our applications, like our data is never really fixtured, right? We always go to an API server to get it. So generally speaking, this first line is always outlook.hal.ajax and then the top level of our API, which I'll talk about in a minute. So we're starting with a resource, then we're getting an embedded resource, right? So here's that rel keyword. So this is telling us that this string could really be anything. I could have called it like the food, or I guess this is tables, right? So like the tables or whatever. So once that's complete, it's going to pass the results into this create models function, which is going to create models of type app.table, and then it's going to add objects to results, right? So this is all asynchronous. This is all promise stuff. This could have been written in some other ways that would end up having a lot of rightward drift. I don't know if you've written a lot of asynchronous stuff that depends on asynchronous stuff that depends on asynchronous stuff. And you're passing in callbacks, right? Your code your tabs start shifting everything over. This allows us to avoid rightward drift by sort of chaining these methods on each other. The food one is doing essentially exactly the same thing, just with a different resource, right, and a different relation. And it's creating instances of a different model. So that's interesting. That gets us models created. But it's not exactly a one-to-one replacement yet, right? So in all this stuff that we deleted here, there was some like computed properties. We were able to link different types of models together. So if I have a table, that gives me access to a tab, and a tab has tab items. So we still need to introduce, or we still need to answer that problem, solve that problem in our code. So that code is in the next commit. So I've added some computed properties, right? So all of these are computed properties. On the table, a table has a collection of has a tab, right? And how do we get access to that from our model? So I've chosen to implement this as an object proxy. My HAL resource is my content object. Is everybody familiar with how object proxy works? No, okay. So object proxy is a special class that has a special property called content. And whatever object you set to the content, the object proxies get and set requests for properties to that object. So that's a fancy way of saying, if I set the content of my object proxy to an object with 3 properties, A, B, and C, my object proxy, when I ask my object proxy, give me object A, or property A, it's going to get the value from its content. Yeah, I'd open up the documentation and show you. We're familiar with that in a lot of ways, like the object controller. Like an object controller proxies requests for properties to its content, right? It's the same mechanism here. So this table has a computer property of tab, and my implementation of that is based on the content property, right? So I get the content property, and I create an instance of the tab model, setting its content to the embedded object. Okay. The tab model has two properties that we're creating as well. A tab has a collection of tab items, and it has sense. So, the peepcode application had sense here, and it's kind of like it's kind of a red herring like why you would have it here. So this is just to maintain compatibility with peepcode. But again, we can see that the HAL stuff allows us to start with an object, create models from it, add it to a collection. That collection had been returned immediately. If this action were dependent on going and getting another response from an API server, we would still have the property would still have an instance of an array. At first, it would be empty. As that data were loaded, the array would be populated. Our data bindings would be updated. The application state would update. And same thing for tab item. Tab item has a food property, and that's returning an instance of the food model. So, not a lot there. Again, that was mostly just replacing these sort of things, right? So tab item, sense, food, tab items, sense. So a real good one-to-one correlation there. So once I got the models updated and stuff, I had to make a few other changes to the peepcode application to get everything to work again. I had to add 2 routes that had been missing, and the only reason I had to add them was to specify a different behavior for the model function. So this model function for the table route is looking up the model for tables, getting that result, and then searching the results for searching those models for an ID that matches params.table ID. In a real application, you wouldn't write this code, right? You would say, go to the API server and request table number, whatever this ID is, right? So, I didn't have a real API server to be using to make that request to, so I kept it like this for simplicity's sake. And the tab route, I don't know, to be honest, I'm not exactly sure why this was necessary. And then I had to specify that the tab controller was an object controller. I'm not really sure why that was necessary either. and when I say that, I mean, I know why it's necessary. I'm not sure why it wasn't necessary in the peepcode application. The peepcode application got away with not specifying a lot of things. I'm not really sure how it got away with it, but whatever. So at this point, we could look at the application, and everything would work. The last thing here, the last commit here, though, is so you might have noticed that everything about APIs and our models and how we're using it has all been read-only so far. But the application isn't read-only. The application has a way of adding food to somebody's tab, right? So in order to support that, I just real quickly wrote an implementation here where, so this is the action, right? Something's going to call the add food action and pass in a food. What I'm doing is I'm getting the current table, getting its tab, telling the tab to add that food. Down here, it's real simply saying, it got cut off. It's saying, okay, I'm a tab, I have tab items, get all the tab items, add a new one, and just create a proxy object passing in the food and its sense. So let's take a look at the application running. So I got my server up here. Yeah. Okay, so this is the peepcode application. Looks familiar, right? We can start at tables 1, 2, 3, 4. We would expect stuff to be pre-populated. 5 and 6. And we can come around here. We can see adding stuff still works. And just to make it really, really clear, oh no. Oh, here. At this step, I had removed Ember Data, so Ember Data is not in there at all, and we've still got everything working super smoothly. So we've seen the application, and now let's talk about a little bit about the differences between what we're doing and what Ember Data is doing, right? So a subtle difference is that Ember Data says you might ask for post 13 30 times in the course of your single page application's lifecycle. Every time you ask for post 13, I'm going to give you the exact same instance of that model. There will only ever be one instance of that model, and we're going to maintain that state. We're going to do the caching. We're going to take care of it all for you. What we're using doesn't do that. So if we ask for table 4 in one place and ask for it in another, we're going to get 2 instances, 2 different models. They'll both have been parsed from the same resource, but they're 2 different instances. So one's caching an app, and what we're doing is using HTTP caching. So caching is pretty hard. It's one of the harder things in computer science. HTTP already has an answer for caching. We don't really want to reinvent HTTP in the application level, in the application layer. So let's stand on the shoulders of giants and take advantage of the browser's ability to handle that cache. Because really, the browser has some sophisticated techniques for communicating with, well, the HTTP protocol has some sophisticated techniques for managing cache, for invalidating cache, for checking, hey, I think I have the latest version. Can you tell me if I do, and if I don't, give me the latest version. HTTP already does all of that. However, if you were working on something and you really did want the same exact instance all the time, it would be really simple to change your find function and apply memoization to that. So memoization is a fancy term for whenever this function gets called, look at its inputs and look those up in some hash to find out if you've ever run for those inputs before. If you have, get that value from that cache. If you haven't, go ahead and run, and then store that value in the cache so that it only ever gets looked up once, or it only ever gets executed once. So pretty easily we can adapt to having cache in the application when we want it, when we need it. Another thing that's different is that
we're not really trying to solve the same problem that Ember Data is trying to solve. So Ember Data, one of the problems Ember Data is trying to solve is you have like this local database or data store, and you might be making changes to it. The user might be, updating names. They might be adding stuff to their cart. They might be doing all this stuff, and you're just updating your local data store. And then you call synchronize, and the magic happens, right? We're going to take this state that you have on your locally in your application, and we're going to attempt to send that to the server, and your persistent data source of record, your database, will magically be updated in all the same ways, and you won't have to think about that at all. And that's really an ambitious goal to have, right? Like, that's some pretty complicated stuff when you start talking about how objects can be related to each other, parent-child relationships. What if a table, like a self-referencing relationship, right? There's a lot of different things there that introduce complexity. So we've stepped back and we said, okay, we don't need our stuff to do that. We really need a way to read data out, and we've got that. And we can separate out the ability to update that data as a completely separate concern, separate code, separate completely. And in fact, this concept already exists in computer science, right? Like the concept of command or query command separation, or that pattern is an established pattern, and there's some benefits to it, and like people think different things about it. If you're interested in it, check it out. But for us, what's really important is that our getting information, that's 90% of what we do is read only. We're an e-commerce site, so we also need to like update a cart and stuff like that. So when we need to update that information, we'll construct a command. We'll send it to some API endpoint, the URL of which we did get through our HAL resource, right? So our application doesn't know anything about URLs. It'll do its thing, and that's all that we need it to do. So let's talk about user experience for a second. Like, a lot of times, a user on our web applications, we want to tell them, okay, you want to add a customer, you're writing a blog post or something. You go ahead and put in your information, you hit send, and we're going to make the application look like the save was instantaneous, you get taken back to the summary view or whatever, you see your new item. In the background, there's an AJAX request going, right, to save that to the database. And we're just going to assume that that's going to be successful and present the application like it's going to be successful. And, in the rare cases where it's not successful, we'll handle it gracefully by, like, popping up a growl message or something to the user saying, hey, the thing you thought you saved, it's not actually saved. You might need to check that again or something, right? And so how would we do that with our stuff? Well, that code that I was showing you, it kind of does that, right? So here we have, this is the commit that's adding support to the application for adding things to a check. And all it's doing is creating an object proxy. It's not even an instance of that model type. It's not the same type, but it has the same properties, right? So we're taking advantage of duck typing. This thing looks exactly like a tab item, so it'll render exactly like a tab item using data binding. So if we were using, like if we had a command that we wanted to ship off to the web server, right? We could be doing that here. Inside the command, we'd say, oh, in case of failure, go ahead and drop this object that we've just added from, go ahead and drop this item from the collection, and that way we can say, oh, your list, it was updated immediately, and it's going to be updated immediately, except for the rare cases where the save request failed, in which case you're going to see it immediately, and a couple seconds later when we realize it failed, it's going to disappear, and maybe we'll show you a different message saying, oh, like, sorry, we're in beta, you know, try again. The kittens are working on it. So that sort of allows us to handle those cases on a one-by-one basis and figure out, okay, what's the best behavior, or what's the behavior that we need here? So that's the end. Does anybody have any questions? Yeah.
You're talking about the memoization. Could you kind of go over that one more time? So you're basically saying that that's how you were doing local caching?
It's a way that we could, right? So you know, there's a function here, right? And this is going to return instances of models. So one thing that we could do, the very first thing that we could do, right, is say, like, var cache. And let's make it a hash, right? So we can say, if cache contains ID, return cache ID, right? If it doesn't, then we're going to do work, and then we're going to say cache ID equals the model. And now, anytime I come into this function for the same ID, I'm only ever doing this work one time. And so memoization is essentially doing this, only they've got like if you use underscore, for example, they have a memoize function, right? So we could say function find ID, and this is just do work. Down here I can say find equals memoize find, and I think maybe this has an underscore in front of it. And so that's replacing this function with a memoized version of this function, and this memoize is essentially just doing exactly this. It's saying every time this function gets called, look up in a cache to see if I've already run it for those inputs. If I have, give it back that same output. If not, then I'll do whatever. So, you know, this would give us, every time I ask for post 13, I would get the same exact instance of that post.
Makes sense. I like it.
Yeah. So like the API for being an Ember model is really, really small, right? Like there's only one function you have to, a find function. And you have to behave a certain way, right? You got to return immediately, populate eventually. But other than that, like, that's all you need. So Ember Data gets you some other stuff like, has my model been loaded? Is it currently in the process of loading, right? Like a lot of times you'll want to display like a little AJAX spinner while your models are loading. At the end, you know, you show the actual result. And so that's really easy to do. Like, you know, here we have, so all of these finds are returning collections. So let's say that we wanted to make this table find take an ID, right? So the result is going to be an instance of a table object, right? We would go to some URL. Then set properties on result, and we return result immediately. Where's that going to this?
Spares.
Ah, right. So, you know, at the beginning I might say result.set is loading true. Okay, I make an AJAX request. Once I get the response, then I set the properties of the model, and then I might say result.set is loading false. and boom, now I have support for, do I need a spinner or not? If this is something you find yourself doing quite regularly, then it would be really easy to break that code out into like a base model class that you
Record
extend
arrays
everything
with
from.
Ember Data actually uses.
Exactly.
So they create, they extend array proxy and call it a record array, and then they pass that back and put the property is loading and a few other things actually right on it.
Yeah.
But you could absolutely do the same thing and still use HAL.
Yeah, like if I mean, for us, like we don't have that many models that we're working with, so you know, to implement this where we need it isn't a big deal. If it were, like you pointed out, like it'd be really easy to write a base model class that has a lot of functionality that you wanted. Like if you wanted like dirty checking, right? You could have that. You could build that really easily too. So like it is stuff you get right out of the box with Ember Data, right? But Ember Data comes with a lot of its own baggage too. So by caveat emptor.
Have you looked at Ember Data enough to know whether it would even be possible to write a HAL adapter for Ember Data?
Brother Herman has looked at that quite a bit.
Yeah, so I've been talking to the guys a bit about that. I think the first step is I'm working on actually building in a HAL serializer into active model serializer, so that I think that's the first step. I think their biggest.
Oh, to actually generate it on the Rails side.
Yes, or yes. So basically, I think that's the first step, because I think a lot of their feedback is, well,
We haven't actually seen
the
practical implementation.
there are plenty. It's the tooling for it, though, as all the Hopla guys here can attest to, is it's a lot of work to do HAL, and they're like, you know, it just doesn't seem like it's something we need if it's like the barrier entry is so high. That if people are going to invest that much time into it, they'll do what we did here. So until like the barrier entry is lowered, then we're not usually moving support in there. So then my answer to them is, okay, I'll lower the barrier entry to build active model serializers with HAL support. So I'll make it basically trivial for you guys to return, for me to return HAL responses now, and then I'll basically, you know, and then we'll build the popularity up. So then there's like, you know, a mob asking for HAL support, and then they'll be happier to do it. Because if no one wants it, then it's a waste of time, right? Which I totally agree. So like, if people want it, then they'll do it. So they're open to it. They're just kind of waiting for the community to get to that point.
For demand.
What kind of problems does HAL solve that the traditional like, JSON API is presenting?
The thing that, when you return just application JSON as your content type, you're returning data. When you're returning HAL as your content type, you're returning an actual object, a type. So I return you back like a response for food. It's actually a food type, and you can identify that because it has certain state to it, and you know, you always go through the root of the API, so only you know like what relation you're going to next. Like the relation is like /rel/food, and the whole reason we use things like actually using URLs in the relations is because what you may mean as food is maybe not what I mean as food, right? So if I actually put a URL in the relation like that, and I make that like hopla.com/rel/food, I actually can then have that be a link, or I can just have something up there that identifies that, what that is, and say like, this is what food means for this application. So when you go to some other application that's using HAL or any kind of hypermedia type, and they have their own definition of food, they document what that definition means, right? So actually I'm telling you what I mean. So instead of just giving you basically back like, the problem with the way Rails does it is they return you the entities, right? They just basically dump you back the database in JSON format. Like, we're great, like, you know, CouchDB does that too, and like, I don't, why am I even going through a Rails application? All you're doing is dumping back to me what's in the database in JSON format. And the other thing is, you know, food might be actually in a relational database. Food might be spread over 3 or 4 tables. So I might have a table with all the types of food, and I might have a table with that actually, you know, links the URLs to the food, or then, you know, for different types of companies, you know, has the price in there. The, you know, data modeling on databases gets very complicated, especially as, you know, the application gets more and more complex. So I shouldn't be tying my front-end application to what my database looks like. My database could be SQL, MongoDB, it can be like Hadoop for all we care. Like, we don't care what the data is stored, what format stored, right? What we actually care about is telling the client, like, I have an object that's being represented as a piece of food. And so then it's very easy for me to tell you, like, here's food, and this is exactly what it is. And if I change my database, like, you're not going to care. So that's kind of the big benefit. The other benefit is, and this, I'm not sure how well this has been proven out. I will definitely preempt this with that. Is by not basically sprinkling the URLs throughout the application, I'm able to actually change what's going on. So if I want to, you know, change the URL for orders or baskets or whatever, I can do that, and I don't need to actually worry about breaking my client because you know, they're not actually constructing URLs.
Yeah, so like as an so he writes the APIs and I help write the application that consumes those APIs, right? And so like we've got something right now that has, so we're an e-commerce site. We've got like, oh, you come, you see a bunch of our products, and you can keep scrolling on this page infinitely, and we're just going to keep showing you all of our products. And so how did we implement that? Like, my application only knows about one single URL, one entry point URL, to get a page of data, right? And the response that I get back has a next link that already has all of the information that the API needs in order to get the next set of data. So that says like, oh, these were the filters that you were searching on. Oh, this is you know, the exact query. We've cached those results so that we can, you know, give you page by page. Here's the cache ID that we're using for that. All of that stuff. Me as the application, I don't have to know any of that. I just say, there's a next link. It's got a URL. Whatever that URL is, go and fetch that. That's my next set of results. That's also going to have a next link. And I just keep following, just keep doing that. And
so maybe you have like some functions like a construct next or a construct find, and you call it on the HAL resource you're dealing with, and then it's able to look at itself and the links and find out where to go for that like next or that find or whatever.
So the construction of that URL would happen at the server, right? So the server would give me back this string.
But like, I guess more for the templated case.
Yeah, so for the templated case, you're right. Yeah, so like I know that I want to follow the find relation, and I, as an application, I know that I need to provide that relation with an ID. Like I can show you what that looks like. Yeah, so here's that HAL function, right? Takes resource relation template variables. It's calling this little helper function down here, template variables. Does some fancy stuff here, but essentially I'm just calling this third-party component URI template, passing in the string URL from the href, so that was this string, and passing in a hash, the variables, and I get the string output, and I just follow that without question, right? So in the past, you know, I've written backbone applications, and the REST server that we had, like our REST implementation, like we didn't really get REST, but you know, we're like struggling to get our way through it kind of thing. And you know, our application had all these URLs hard-coded, and it was like, okay, if we're going to change this URL, we need to go change in the application. And how's the application going to communicate this back to the server? Well, the application, when working with a HAL API, doesn't need to know any of that stuff. The server can change it whenever it wants, right? Because we've all agreed upon a standard for templating URLs. And so to me as an application developer, that's been the biggest get out of all of this.
So you standardize on these links, and then
No relations.
or the
On self, next, find, admin, basket.
those right, okay, the relation side of the link.
Yeah, so my application would have the
Because
word
these are
find
called the
hard-coded.
links property? Yeah.
Yeah.
Those the left hand side are called the link relation, and the
then
right
there's
hand
the
side is called the link URL, the link href.
Okay.
Yeah.
So my application knows is something going to be a link or an embedded, and it knows what the rels are.
Got it.
And
then you
everything
don't
else
have
can
to
change,
have-
right.
Yeah, I see.
The real world example of this is Ken talked about the infinite scroll thing. we actually stood that up on MySQL because of time constraints, and so we have like this super long URL in there. He doesn't have to construct it, and the API guys hate their lives for doing all this stuff in MySQL. It's very painful, and so we're standing up Solar instances to support this, and the URL is going to change. And Ken's not going to update a line of his code. It's just we're going to just present him a new URL for that link relation, and his code's just going to work because we're going to return him the exact same response. So I literally, because essentially the Solar database wants different inputs than MySQL, so it's just going to kind of quote unquote work, and Ken's not going to have to even know we did it. We're not going to have to communicate.
And you know, like if you hear like academic conversations about REST, like that's sort of what they promise, what REST is supposed to promise, right? And so like, for me as some guy who doesn't get the academic aspects of REST at all, but understands what it's supposed to do, like this is the first time as a application developer I've ever seen those promises, anything fulfill those promises, right? And yeah, it's been pretty awesome.
Yeah, I think it's very helpful to understand what you're extracting here.
Yeah.
Would you ever deal with, does that essentially get away with versioning your API?
Yeah, so it actually does. So if you've ever seen someone actually put a version in their content type response, that's like absolute worst thing you can do, right? That's not very hypermedia friendly. But HAL, and no hypermedia API does it the exact same way. The cool thing that HAL does is you actually can version the link relations. So what you actually can do is, if you're not familiar with the term, it's called a query. So Ken was showing this really long form syntax of putting the entire URL in there, like http://hotlook.com/rels. You actually can take that and shorten that up to like a small string and declare that at the top of your HAL response. Like you can call like HL, for example, for Outlook. So you like HL : and then like orders or whatever. You also can mess around with that, and you can define different queries for different versioning. So you can do, you can do like Rails/v2/orders, or you could do HL v2 : orders. So you can actually version on the relation level rather than the entire API level. And if you talk to anybody like us, go talk to GitHub, go talk to Twitter, trying to move from one version to the next version of an entire like set of API endpoints to another, you just want to pull your hair out. Like we're going through right now, it's an absolute nightmare. I cannot use enough swear words to define the pain that is involved in doing that. So basically the whole reason we're moving over to HAL is to allow us to start versioning that way. So I can say, if the website was needed to something and the iOS site was all stuck on the old way of doing it because they only can release once a month and we release like 8 times a day on the website, I can basically define a new version, give it to the front-end team, and the iOS team comes in a month later and picks it up, and then we can just deprecate the version of that one endpoint instead of cutting a whole new API for it, right?
Herman, do you think that another advantage to HAL is the self-documenting nature of hyperlinking from root?
Yeah, one of the tenets of hypermedia is that you're supposed to be able to give someone just the root of the URL and like lock them in a room, and they should be able to understand like what your API is doing. Like one of the things we do is document the link relations and say like, here's what this is supposed to do. Here's an example response. This is the context that you're supposed to use it. And then as you kind of start from the root, you go like, oh, so the root returns me back like a link to the events page. Well, I guess then I should be directing my client to the events page. And then, oh, the events page returns a bunch of links to maybe like the different catalogs we have going on that day, like catalogs for those events, and like maybe like a link to the accounts section. It's like, oh, okay, well, I should lead my client into, you can either go to the catalogs or you can go to your account section to like manage your preferences or whatnot. So rather than just me, if you ever looked at like Twitter's REST API, it basically dumped like 50 endpoints at you, and it's like, where do I start? How do these relate to each other? And you end up like kind of like crawling through all of their guts of what this stuff's doing to figure out like even where to start. So it's easier said than done, but it is possible with hypermedia.
So are you guys not using Rails on the server?
No, we're not using Rails on the server. Yeah.
We're a PHP shop. We've been around for 5 years, and there's no way when we started Rails was even up to the task of dealing with the stuff that we were dealing with. Now, I'm sure we could scale with Rails fine. but at the time, PHP was essentially like the thing to do. We're not proud of it.
Yeah, Mr. Lauren.
You were talking about relying on the browser to do your caching, and that's probably a tough pill for, well, certainly me to swallow. But I get what you're saying as far as the memoizing. But when you're talking about HAL responses that have embedded objects in them, has there been any development toward notifying the browser, hey, this sub-object that I got as part of something else, you can cache it for me at this URL?
No, so I think if you wanted to be able to do that, you would spin those things out so that they weren't embedded resources, right? If you promote them to be like a top-level resource that you get with a request, the browser can then be involved in caching that request or that response. And when you make a subsequent request, knowing about, like, hey, I already know about this stuff, and I can short circuit and not have to download everything. But I don't think we'd try and like call into browser APIs to say, hey, cache this using browser cache, as opposed to us just storing it in memory, for example.
Well, I think the good thing you have is you have these URLs. I mean, you could actually build on what he's showing and create kind of this global record cache that Ember Data does, that the keys would be that URL. So when before it went to go hit your API, it check that same href tag to see if it's in some array.
Yes.
Stored.
My concern was actually that you were talking about the difficulty of a cache is knowing when to expire things and all the CS complexities and all of that. And if you push something like that to the browser, then it's got all the implementation of when do we expire records, so on and so forth. So as an alternative to pushing it to the browser, I haven't heard of any further development as far as the HAL spec, since it seems to have sprung from the ether fully formed. Has there been any discussion of, okay, if I've got an embedded link, how do I annotate when that should expire or something like that?
Correct me if I'm wrong, but yeah, Mr. Herman.
So this is the biggest criticism that IETF had when HAL is in like draft status in terms of like RFCs, and so Mike Kelly, who is the author of HAL, recently submitted his RFC to IETF and asked for feedback and then to be actually put in as a true RFC. And that was the biggest criticism, the exact thing that you brought up, Lauren, of you can't tell in an embedded object, like there's no HTTP headers really to say like, hey, like this is what you should do. And it's kind of gone back and forth because, I mean, it's not an easy thing to do, right? HAL's hard enough, I think, to construct, as you know, and now you to actually expect the servers to put in like the right kind of headers like that even seems like a bigger barrier. So I actually think the conversation's still going on and they've not decided anything yet. But yeah, it was something that was brought up. I think for the most part, as we've seen like in practice, though, we really aren't. We kind of actually treat the response as more of an atomic object as we embed the stuff, and less of like we're trying to like fake out HTTP requests here by like embedding things. Like I don't think we're using embeds as caching, and more of we're using embeds as kind of intelligent grouping of resources together, so that it makes sense when I'm returning you a collection that I return you the items in that collection, not just like the metadata count on that collection, right? So if we think of embeds like that as like they're actually just intelligent groupings of the data, rather than trying to like sidestep.
They're a mechanism for caching.
Right. I don't think they're mechanisms for caching. I really think they're better used as intelligent groupings. And again, hand wave all the caching over to something more complex like local storage or HTTP or something like that, like true HTTP.
Yeah, that's kind of why I was saying, that would make sense to push back to the browser.
Yeah, for sure.
I think I'm way over time, so any other questions? Thank you very much.